Hello there, everyone. Thanks very much for joining us. I'm Jane, the Communications Manager for Iomart. I hope you're all well and looking forward to hearing from our experts over the next half an hour or so. In a moment, we're going to be hearing from Andy Sinclair, who's Iomart's Innovation Director, and from Richie Fry, the Channel Systems Engineer with Gartner leader Silver Peak. We'll just give it a minute or so as we wait. We've got quite a few people hopefully joining us for this session today. Just to remind you, the aim of the session is to give you tangible insight into the challenges of the traditional wide area network and how a software-defined approach can help you overcome them. So we've got a few people still to join us. Thanks very much to everyone who has tuned in today. We're going to be delivering this from our homes, obviously. So if you do have any connection issues, it'll probably be just best for you to log off and log back on and rejoin us if you can. Hopefully you won't have any problems though. I think we're nearly ready. Just a reminder that if you'd like to ask a question, we'll take the questions at the end. So please type into the Q&A box that you see on your screen and we'll do our best to answer them all at the end of the two presentations. Just give it another moment or two. Hope everybody's sitting comfortably and had a good and productive day so far. Right, I think we'll get going if that's okay. I think we're ready to start. So thanks very much everyone for joining us, and I'll hand you straight over to Andy Sinclair. Hi, Andy.
Hi there. So I think we'll just do a little bit of an introduction to Iomart in the first instance, for those of you who aren't familiar with Iomart and for those of you who are, maybe just a little bit of a recap. So Iomart's a hybrid cloud service provider operating out of the UK. Its head office is in sunny Glasgow. It's got an annual turnover of exceeding 100 million a year. And 90% of that is recurring revenue. So we're a very financially stable business model. We support over 4,500 clients across the UK, covering lots of different sectors. We own and operate 13 data centers in the UK and have a further 26 points of presence globally as well. We have a national dark fiber network that connects all of our services. And the key core areas that we focus on are core infrastructure, data protection, data management, security, connectivity, and the digital workspace, all backed with our 24/7, 365 support. We're the most ISO accredited cloud service provider in the UK, and we enable organizations up and down the UK to deliver their unique services to their users and their customers, covering things like underpinning 3 million copyrights for music via data protection globally, and also supporting online gamers, serving over 1 million online gamers each month, which no doubt has probably seen quite a spike recently. As I mentioned in the last slide, Imart has a significant global footprint with 13 data centers in the UK and a further 26 points of presence globally. Our extended global network interconnects our cloud platforms located, of course, in the UK, but also available in Dubai, Singapore, Tokyo, Sacramento, and Virginia. So a quick overview of the agenda. We'll start in part one by looking at the challenges that we as a service provider tend to find that most businesses come up against when dealing with the traditional WAN. Following this in part two, we'll revisit those challenges and detail how they're solved with the application of SD-WAN. And then in part three, I'll hand over to Ritchie Fry, who'll highlight why the journey from A to B is better with Silver Peak. And lastly, Jane will wrap up with any questions you might have. So let's just jump in. Now, the first problem is availability. And availability is the total amount of uptime within a given fixed period, usually presented as a percentage. Now, there are some high-level specific issues that are associated with availability, and these are blackouts, brownouts, and some application-specific issues. Now, blackouts are really straightforward. It's a complete loss of service, most commonly caused by a device or router failure or a circuit issue such as a fiber break. Now, brownouts, these are service issues that are much harder to identify than a traditional blackout, as the circuit reports as being online and available. However, sometimes there are performance issues across the line, perhaps severe performance issues, or perhaps they only manifest themselves when, let's say, a circuit reaches 50% of its capacity. Now, enterprises usually have a lot of trouble when reporting brownouts to their telcos, because if you're using the industry standard monitoring tools that come with most circuits, it's very hard to actually prove that those issues exist. The last issue to highlight is application-specific availability issues. And these are usually due to congestion. Now, the classic example of this is voice over IP traffic, where congestion can result in dropped packets, which become extremely noticeable to the end users when they're on a call. There are ways to navigate this issue in the traditional WAN, such as quality of service. Out with voice, however, these can be relatively challenging to configure and are fairly inflexible due to the complexity of having to implement such advanced configuration. Of course, nowadays, part of the answer to this is simply just to increase the size of the pipe. If your line is never congested, quality of service is never a problem. Of course, if you can't increase the size of your pipe, then you do have a problem. The next major challenge is capacity management. Having to manage the vast explosion of data that has taken place in the last 2 decades is no easy feat. I think this quote you'll see in the slide, which is 90% of all of the world's data was created in 2010 onwards, succinctly kind of outlines the exponential growth curve. And what's really interesting is that quote was written in 2013. And that exponential growth curve has been continuing unabated since then. Capacity management is becoming a real challenge, especially in individual circuits. A classic example of that is something that we frequently encounter is, let's say, when an enterprise has a WAN circuit with 100 megabit per second of available bandwidth. If that circuit is maxed out, then what's your next steps? Well, if you're lucky enough to have a 100 megabit circuit and a 1 gigabit bearer, then it's relatively straightforward. You contact your telco and you get them to increase the committed data rate of your subscription. But if you happen to be running a committed data rate of 100 megabit per second on a 100 megabit bearer, well, that's a bit more of an issue. And that business might be somewhere into a 3 to 5 year contract. And if that customer's maxing out that link, they might have to pay some relatively eye-watering costs to see that line upgraded to a 1 gigabit bearer. Now, they could deploy an additional circuit and load balance the traffic across both links. But that type of traffic engineering is relatively rudimentary, and the financial implications of such an MPLS strategy can be significant. The explosion of data is causing capacity issues other than just bandwidth. The more throughput you have, the more inspection you require, which requires ever faster devices. In the last decade, there's been a significant shift of network traffic from east-west traffic, which is traffic within the enterprise or going across the WAN, to more of a north-south pattern as more and more services are consumed via the internet in the cloud. There's still a place for a resilient wide area network. It's just that the remote end of that WAN link will more than likely now be a cloud infrastructure provider or a SaaS provider. This means more traditional MPLS WAN networks that used to be quite busy with internal traffic are now quite quiet. And the majority of traffic traversing the WAN is actually internet traffic destined for a centralized internet breakout. This makes managing internet capacity and the throughput of any security devices at that location a real challenge. And for most enterprise admins, the operational expense of deploying and securing an internet breakout at each location becomes prohibitive. Extremely long commitments with telco providers, as I'm sure we're all aware, aren't usually desirable. Now, it's common to have a 12-month or 3-year contract for a leased line. However, if you're connecting those lease lines into a service provider's MPLS core to facilitate an enterprise MPLS cloud, then those contracts are usually between 3, 5, or 7 years. Now, that is a long time to be in a relationship, particularly if it's an unhappy one. When dealing with traditional MPLS providers, requesting a new circuit isn't that straightforward a task, especially not if you need it in a hurry. How often have we all ordered a lease line and been quoted a 30, 60, or 90-day lead time by the telco, only to miss that mark, and not by a little, but by quite a lot? Now, that's not helpful. Certainly not if you have a go-live date for a new site that's set in stone, or you're having capacity issues and require a new bearer deployed, as we mentioned in the previous slide. And even if you get those lease lines deployed in a reasonable time, they still require manual device configuration at the last mile and also in the core, require engineers to be scheduled and sent on site. Lastly, remote management of those devices is complex, and unique custom configurations per device. And in a number of cases, these devices also require engineers to be sent on site, which negatively impacts the lead time on any change to those devices. When I talk about transparency, I'm talking about really what's going on inside the WAN. So if anyone's ordered a WAN circuit in the last 10 to 20 years, you'll almost certainly be familiar with this image, which is the classic RRD style graph. And this is what you'll have received as your network monitoring. This type of legacy SNMP monitoring shows 3 things in total. It shows if the circuit was up, it shows the utilization of the link, and although not on this image, you'll usually receive a graph that shows the latency on the link as well. And that's it. There's no other intelligence into what's actually going on in the WAN. And this graph, I mean, it's not a particularly healthy graph by the looks of it, but in order to figure out what was going on, there would have to be some serious investigation. You know, I couldn't just look at this and figure out at a glance what was actually happening within that traffic flow. The last challenge, of course, is the value of the service that you're receiving. On the left column, you'll see the components of a traditional MPLS service. Without vast investment in a resilient MPLS core, there's no way to achieve this service for most enterprises other than leveraging a service provider. DIY SD-WAN seems like it could be a reasonable option, but what's missing from this picture is the management of the underlying telco last mile circuits. And ideally, those circuits would be from multiple providers and also leveraging multiple different types of transit technology. On top of that, last mile procurement and management that we just mentioned, there's also WAN optimization to configure. There's monitoring, 24/7 monitoring, and 24/7 365 support that would have to be included. And of course, as this is now a multi-cloud world in which we live, there's also the management of SD-WAN connectivity to various different providers. So what at first seems like a cost-effective solution, the more you look at it, it starts to look very different. So how can we solve those issues with SD-WAN? Well, let's look at our availability challenge. We have one circuit and could have perhaps required maybe an additional 20 megabit per second of capacity. With SD-WAN, we can add an additional circuit into the pool. So here, what we've done is we've added in a consumer EOF TTC broadband circuit with a 300 megabit per second downstream subscription. So we'll add in another circuit. This time it's a 4G LTE circuit, which can do between 150 to 300 megabit per second. So that's now 3 separate circuits. And the beauty of Silverpeak is that its software-defined overlay allows the discrete circuits to act as a single link. So what we now have is multiple resilient paths, multiple resilient providers. We have different types of layer 1 transit, from optical to LTE. Our application-specific availability is resolved, as even though we don't have quality of service, we do have Silverpeak's advanced forward error correction and real-time packet order correction, which ensures an enterprise's critical application traffic, such as voice traffic, arrives when it's supposed to, and importantly, where it's supposed to. Capacity management is answered as now we have multiple links. The fundamental capacity issue goes away. However, Silverpeak isn't doing rudimentary load balancing. We can enforce policy so that our most valuable traffic adopts certain links, such as our VoIP traffic, as you can see in the diagram, is spread across all 3 circuits. And our less valuable traffic, for example, Netflix streaming at lunchtime, leverages our lower cost consumer EOF TTC links. The challenge of transiting internet traffic across a traditional MPLS network and security device throughput is answered when we swap out those private MPLS circuits for multiple internet breakouts at each of the enterprise locations. Silverpeak and Iomart work with a multitude of security partners, an example of which would be Zscaler, which integrates into Silverpeak's Unity Orchestrator and delivers a distributed security layer with centralized security and policy management, all as a managed service across all of your Silverpeak devices.
In terms of business agility, the challenge of extremely long-term and flexible relationships with telco providers becomes less of an issue. The ability to use SD-WAN on any provider and over any type of underlying internet connection, while also negating the requirement for a private MPLS routing instance. SD-WAN shifts the routing engine of your network from the telco back to the enterprise or the service provider. This means the enterprise can enjoy much shorter contracts, from 12 months to 3 years, the same as what you would expect with a standard point-to-point circuit. And when ordering those links, well, unfortunately, even with excellent project management, there's nothing you or I can do about the provisioning lead time of telco providers. But as Silverpeak works with all underlying types of internet connection, and a variety of different layer 1 technologies is actually recommended, provisioning a low lead time EAD or LTE circuit allows your business to get that new office up and running, even if your MPLS DIA circuit misses its expected provisioning date. And when it comes to the complex task of configuring the last mile, in a large number of cases, Silverpeak removes the requirement for an on-site engineer, as Silverpeak employs centralized zero-touch provisioning for its SD-WAN routing devices. Devices are deployed and configured by your managed service provider through the Silverpeak Unity Orchestrator, removing the necessity for local and custom configurations on each last-mile routing device. Lastly, remote management of those devices is handled in the very same way through Unity Orchestrator managed by Iomart, whose engineering teams go through a standard requirement gathering, analysis, and design process. They create, implement, and maintain effective routing and security policies for your organization.
Transparency is taken to kind of a whole new level with Silverpeak. Gone are the days of kind of a opaque RRD style graph. Silverpeak provides real-time monitoring of availability, bandwidth, latency, and jitter. It also identifies individual discrete applications that are transiting across your traffic flow, an example of which is Office 365. It allows you to identify specific individual traffic flows to your users, such as traffic to YouTube, Facebook, or Google. As more of the world consumes SaaS applications, such as Salesforce.com, Silverpeak has the advanced ability to be able to identify the most optimal ingress and egress points, effectively the internet connection points to those services, and leverage them. And along with adaptive path selection and compression and deduplication, Silverpeak is fundamentally focused on providing the most optimal and effective path to your destination. Lastly, the value of managed SD-WAN from Iomart. Well, Iomart, on the left-hand side, Iomart consultants can assist with scoping, design, implementing, and configuration of Silverpeak SD-WAN for our customers. The ongoing optimization of that network, policy management, security, monitoring, support, and of course, onboarding of any additional new cloud services into that WAN will fall to the enterprise IT teams. However, if you have a skilled in-house network engineer, then this absolutely might be a suitable option for your business. However, if you don't, and you don't want to make managing a WAN a critical focus of your business, a fully managed SD-WAN service from Iomart could be exactly what you're after. From day-to-day managing of the telcos to leveraging our 24/7, 365 support. So I'm just going to hand over now to Richie Fry from Silverpeak.
Right, thank you, Andrew. It's much appreciated. Good afternoon, everybody, and thank you for taking your time today. My name is Richie Fry. I'm the Channel SE for Silverpeak for the whole of the EMEA region, actually. So I've got quite a large region. Now I'm going to attempt to do a smooth handover here. Andrew, I think, yes, no, I do not need to do anything. I can just take over. And hopefully, guys, you should see my screen very shortly. There we go. Okay. Andrew, can you confirm that you guys can see my screen there now? I'll take that as a yes, guys, and carry on. Right. So first, I'd like to start my presentation actually with a question. And that is, what does our road infrastructure and our data networks have in common? And the answer, of course, is traffic, and generally, unfortunately, lots of it. And actually, many of the issues we suffer on our roads today are analogous to the issues that we suffer in our networks. So let's take some examples. And I'm sure you guys could think of many more. Think of single carriageways, ones which should have been turned into dual carriageways years ago. Well, that's a simile for our network bandwidth issues, right? We know that journeys that are long distance, that are many miles, they will take a long time. And in network terms, this is latency, and distance is the biggest cause of a latent network delay. When we are traveling and enjoying ourselves traveling through the countryside, and we end up with lorries and tractors and caravans in front of us, and they drag down our overall speed. And, when we get stuck behind them and the frustration, well, we think about it, that's like our slow and bulky applications hogging all the bandwidth and not letting that much quicker real-time traffic through. And what about the frustration, perhaps, depending on where you live, what about the frustration of having to travel in the wrong direction, actually, to join a motorway to begin your journey? Well, if you think about it, that's similar to that traditional hub and spoke architecture whereby the internet breaks out in the DC and you've got to send your data in the wrong direction, sometimes a long way, before it can turn around again to break out to the internet. Well, what we have on this slide for anybody who doesn't recognize it is the navigation app Waze. Now, Waze exploded onto the marketplace and quickly became the #1 choice for those who tried it, right? Waze takes multiple sources of information, including actually its own user community, to better understand network conditions. And this enables it to offer the best route initially, but to also very quickly change that route if conditions ahead change. Now, to be honest, right, any navigation software should be able to give you the best route when conditions are perfect, but it was Waze's ability to deal with deteriorating network conditions that sets it apart. And that's a great analogy with us here at Silver Peak SD-WAN. Our ability to get the user to the application in the quickest and most efficient way using the best route available. But instead of motorways, A roads, B roads, Silver Peak can use MPLS, broadband, 4G, satellite. We're agnostic to the WAN, okay? We can use any of these things. And just like that sat-nav analogy, anybody should be able to offer you a reasonable user experience in perfect network conditions. However, just like Waze, it's Silver Peak that leads the industry in offering a great user experience when conditions are less than perfect, which, let's face it, in an ever-increasing internet, ever-increasing cloud-based world, that's a frequently occurring challenge. So here we have 4 key pillars and the foundations really of the Silver Peak philosophy. Silver Peak Edge Connect has been designed from day one to help ensure that business drives the application performance in the way that the business wants, as opposed to the old way whereby the business had to adhere to the constraints of the network architecture. Our SD-WAN configuration is built through our business intent policies, which are heavily automated, and they allow the business to manipulate network characteristics based upon the application's requirements, right? Not what the network dictates. Moving on to the second column, so for me, the most important advantage of the Silver Peak technology is our ability to deliver the highest quality of experience in the marketplace. Delivering a high quality experience is easy. Just remember that Waze analogy. It's easy when conditions are perfect, but as we move into an internet-focused world, we meet different challenges. And Silver Peak can offer that great user experience even in degraded network conditions. This ensures that users get that sort of blazingly fast application performance, regardless of the WAN underlay type. Moving on, there's a high degree of machine learning and AI built into our technology. Our founder and CEO, David Hughes, has a doctorate in AI and machine learning. Now, this enables us to choose intelligently the most direct path to an application, allows us to change immediately if conditions change, and even to correct and replace missing data if packet loss becomes an issue. Andrew touched on this with the forward error correction and the path condition. And lastly, the unified platform. Okay, so this, we have a single management platform, a genuine single management platform, where all the configuration, the monitoring, the troubleshooting, the network visibility, and the device backup are managed. More importantly, we've got 5 technologies, okay, and they're combined into a single technology stack. We've got the SD-WAN, the OneUp, the routing, the firewall, network visibility, all running under a single platform. Now, in this slide, I'll take you through some independent testing conducted by Miacom. Okay, so you can verify this report yourself. If you just Google Miacom and Silver Peak, you'll see the report on our website, but you'll see it on Miacom's as well. So I encourage you to download it from there, read the full report. The aim of this slide is to show you the effect really that Silver Peak technology can have on business voice calls when traversing broadband internet circuits. But although this is about voice, you can refer it to anything, because if you can make G711 codec work, you can get anything working. It's a very old voice protocol, right? And when people are contemplating moving from MPLS to broadband internet, perhaps it's the voice actually that people are likely to be concerned about, because generally you could probably make your file transfers or whatever work over internet. It's that voice that would probably concern you most, because it's most susceptible to delay and packet loss, etc. Now back to this graph. Down the left-hand side of the graph, we can see what's known as the mean opinion score, or the MOS score. It's effectively a way of grading the quality of a call. Generally, calls scoring above 3.5 will be regarded as perfectly high quality by the user. Then you've got that area sort of 3 to 3.5, where it's probably going to be okay, but you start to reach a danger area below that. Now, if we look at the red line, then this is a voice call over broadband with no Silver Peak technology. And we can see that this call degrades at around 1% packet loss. And that's a problem, right? Well, it's a problem for broadband internet because 1% packet loss is considered the upper level of acceptable for broadband services. If we keep a single link, but introduce silver peak path conditioning technology that Andrew touched on, we can see that we can experience roughly 6% packet loss before we start to enter that danger area. And that would be an exceptionally poor performing line now. So we've got this massively underperforming line, but we can still run a business call over it. And this is a massive improvement. And it's clear here, even on the single link, the benefits that Silver Peak can bring, even a single connection site. Excuse me, goes on. Yeah. So most of our customers, however, right, they tend to use dual links at a branch when they move to our SD-WAN service. And we can see that the dramatic effect this would have on a voice call. Now, even in the unlikely scenario which we've got here, where both links are suffering, I don't know, devastating packet loss, I guess you call it, we can see that we're able to deliver a business quality voice call of between 15 and 20% packet loss on both links at the same time. So this really should give our customers the confidence that they can move to a broadband-based infrastructure without loss of user experience. Okay, so when people consider moving from MPLS to perhaps a broadband service, LTE, etc., they assume they'll see a reduction in application availability. However, this isn't necessarily the case. Taking Kellogg's, for example, when they moved from MPLS to internet circuits using Silver Peak technology, they reported a 95% reduction in downtime. Now, on this slide, we can see that an MPLS circuit running with 99.5% availability will give us approximately 44 hours of downtime a year. The internet circuit, on the other hand, with that 98%, that's a pretty poor internet circuit, by the way, but it'll give us 175 hours of downtime a year. If we look at this table, okay, then we can see that by combining both of these MPLS and the internet circuit, okay, we can see that on the second line, we'd reduce the downtime to less than 1 hour per year. Perhaps more importantly, we could take both the internet circuits, both of those 98s, and you know, let's be honest, they're both very poor circuits, but we could combine them to offer 3.5 hours downtime per year, as opposed to that 44 hours we got with that single MPLS link. If you were thinking internet, you're most likely to be in the 99 range, in which case you're essentially less than an hour downtime a year. So not all SD-WANs are the same. That's the same with any technology. And many vendors are on different points in their journey. Right? Now, there's only 2 leaders in the Gartner Magic Quadrant, and we are, of course, one of those. You've got your table stakes and your basic SD-WANs providing basic connectivity, basic path selection. Perhaps you get some automation templates, but you lack the functionality to do much more. Now, for some businesses, that's all they need. At least that's all they think they need, and they may need at this moment in time, but that doesn't necessarily future-proof them for further cloud transformation. And actually, we see this all the time. Customers making a decision otherwise, realizing they've made a bad choice, and then coming back to Silver Peak to get the job done correctly. The more businesses rely on their network, though, to run their businesses, the more they need the functionality of an advanced SD-WAN and a new WAN edge. Features like full lifecycle orchestration, integrated automation, advanced security. They can only be offered by probably a handful of providers. Even fewer have moved that step further to offer additional technologies to help them unify that platform. The benefits of self-learning, continuous adaptation, they really start at this level, along with the advanced edge-to-edge security. Now, Silver Peak is striving to be a fully self-driving WAN. Okay, that's how we refer to it internally, self-driving WAN. And while no company can fully offer this today, we're well on our way and we're ahead of the pack. The Silver Peak vision is of a product that's almost fully automated and totally reliant on AI to offer unrivaled user experience, little manual input. So forward-thinking customers are looking for technologies that operate at these higher levels, and Silver Peak is at the forefront of these advances. Here's a depiction of the magic of Edge Connect, if you like. With Silver Peak Edge Connect at the WAN edge, we're able to create a thin branch. There's a lot of talking about this in all directions, about the thin branch, where necessary functions such as a stateful firewall, zone-based firewall, routing, SD-WAN, WANUp, network visibility, all in one device. As the only solution that can identify 10,000 applications. Okay? I'll repeat that, 10,000 applications, and we recognize them uniquely on the first packet. We can immediately direct traffic over the appropriate link, getting the highest performance and optimal bandwidth utilization. And these links can be MPLS, internet services, DIA, DSL, broadband, 4G, satellite. We really don't mind. More complex and sophisticated security functions such as IDS and WAF can be carried out outside the branch, where Edge Connect easily service change to a centralized security solution like Zscaler, for instance, where we've got full automation and you can actually even control some of the Zscaler functionality from the orchestrator itself. We can extend your SD-WAN fabric to easily include the likes of Azure, AWS, Google, Oracle Cloud, so you can make those areas part of your SD-WAN fabric. And we're a software company. Okay, we don't need special ASICs to run our software. So our products work as well in those environments, in those cloud environments, software environments, as they do at the hardware on the branch. And lastly, we'll give you great user experience, even on your voice and video applications, over poor or degraded networks. So on top of that improvement in end user experience, all of this will save you money through better bandwidth utilization, fewer branch of devices, simplified automated orchestration. So what are we doing with Microsoft Cloud Services? Obviously, there's a large, there's an awful lot of cloud services out there, but let's be honest, the vast bulk of us out here are using Microsoft Cloud Services, I guess specifically Office 365. So let's talk about Microsoft now. A lot of vendors will tell you that they can connect to Microsoft Cloud Services, and they probably can. But Silver Peak is one of only a handful of vendors that have gone beyond that. So we've teamed up with Microsoft, full partnership, working to ensure that customers get the best performance when accessing Microsoft Cloud applications. We are a full Microsoft Office 365 networking partner. Guys, look this up. You will find there are only 6 networking partners in total, and only 2 or 3 of those are SD-WAN, okay? So what that means is that we've been awarded a Microsoft designation of Works with Office 365, and this is Microsoft's recognition that we can enhance the Office 365 experience. This means we're easily integrated with Microsoft Cloud Services. Customers are able to host Silver Peak Edge Connects within Microsoft Azure, making this fully part of the SD-WAN fabric. We've got full automation for Azure Virtual WAN, making it easy to extend your SD-WAN fabric. We've also got full automation for branch connectivity for Office 365. And as one of those few Microsoft partners who've been allowed access to the Microsoft APIs, that means we'll get your Office 365 traffic. It'll always be directed to the nearest Microsoft point of presence, minimizing that delay and giving you a great end user experience. Remember, we do that. We'll identify that application on the first packet. So from the moment you press the enter button, bang, you'll be going the most efficient route. Okay? And you'll see actually throughout, automation plays a large part of Silver Peak Edge Connect technology, particularly when connecting to third-party services. And this makes the product easier to manage and saves businesses many man-hours in training costs. So Andrew's already touched on, we've got high levels of network visibility built into the product. Orchestrator is a great place for network administrators to understand what's happening on the network. For example, it's very easy to see what applications are being consumed at a site or across a network. At a glance, you'll be able to see locations suffering from packet loss or latency, or even how heavily remote sites are consuming the amount of bandwidth that they got. You know, do you need to look at upgrading the circuit, or perhaps a better option, look at WAN optimization, which I'll talk about in a moment. All of this information is available on demand, but it's also available as scheduled reports for you guys out there that network managers and perhaps have to report to the business. You can write, you can just get it to simply generate a report for you on a daily basis, which will give the business everything they need to know about that network, or about your network that you're trying to manage. So at the top of the slide, we can see that traditional remote branch, multiple devices supporting multiple technologies. We've got routers, firewalls, OneUp, and now we want to add SD-WAN. Also, we're missing that visibility we talked about here. So that's something else actually that could be in place. This architecture is extremely complex and difficult to configure and manage. There's multiple devices, multiple support contracts, skill levels required to support this. It's all very inefficient. It's very power inefficient as well, actually, because we've got this is a hot topic these days, isn't it? We've got multiple devices consuming power, and we've got the CO2 penalties associated with that. And lastly, this architecture is expensive, right? Multiple devices to purchase, multiple expensive support contracts, etc. The Silver Peak architecture models a unified platform, 5 technologies: SD-WAN, OneUp, firewalls, routing, yes, OSPF, BGP, all of that. And visibility, and we've got it in one platform. It's simple to manage through the orchestrator, and there's only one skill set required. It could be deployed in minutes. They don't have to have the skill at the site either. You can also make use of broadband, for example. Andrew touched on this. You could make use of broadband, and you could have that site up running very, very quickly. You may even wish to leverage something like 4G. Perhaps you want to leverage full-time, or maybe you'd like to leverage 4G just to get a site up very, very quickly. We have many customers that do that. They'll bring a site up using 4G and get that running until they've got their full WAN infrastructure in place. Lastly, there's many savings to be made. Savings on WAN circuit costs, hardware purchase, maintenance contracts, etc. So Silver Peak's been delivering its best-in-breed WAN optimization technology since 2004, and has been a Gartner Magic Quadrant leader in OneUp since then, or since that quadrant was developed. Now, WAN optimization has 2 main weapons in its armory. The first is TCP acceleration, and the main benefit of this group of technologies is to dissolve distance. Okay, so that is, they're designed to dramatically reduce the effects of latency. As bandwidth has become cheaper, latency actually has overtaken it to become the main enemy of performance. And contrary to popular belief, latency cannot be cured by adding more bandwidth. Bandwidth, however, is the domain of deduplication, and that's all about reducing the amount of bandwidth that an application requires. This will vary depending on the application, but it could well be in excess of 90%. So I recently saw a customer, he did a data transfer, it'd been running for a month, and he transferred 4.5 terabytes of data over the course of a single TCP session over a month. It was replication traffic. But what he actually shipped across the WAN was 5 gig. So I'll repeat that, 4.5 terabytes of data went over the WAN as 5 gigabytes. Now, not only did this improve dramatically the transfer times, it actually meant he was getting his replications done within a window he needed to, but it also greatly reduced the cost of transferring that data from a cloud platform where he was paying for the data that had to egress. He effectively was getting his boost for free because it was more than paying for the money of the egress data. So guys, I think you'll be pleased to hear that's pretty much me finished. And now I'm going to open up for any questions.
Thanks very much, Richie. Jane back here, and to Andy. Really interesting presentations there, and hopefully, as Richie says there, it shows how SD-WAN might be the answer to simplifying and optimizing your network management. There are a couple of questions, so Richie and Andy, if you can pop your hats back on again and answer these, that would be great. Richie, this one's probably for you. Says, when you were talking about VoIP over internet, you said that the SD-WAN service could deliver voice quality even with up to 20% packet loss. Somebody's asking how would that work? How does it do that?
Okay, well that's a really good question, because actually Andrew touched on the technology that we use. Actually, do you know what? I'm going to go freestyle here. Sorry, don't everybody panic. I'm going to present the slide that I actually hid. So I think I'll just put it on the screen. It might just make the explanation a little bit easier. Hopefully you can see that. So the technology that Andrew touched on is called path conditioning, and it uses forward error correction. Now, if we look at the top of this slide deck, what we can see here is a typical flow of real-time traffic. Let's think voice, okay? This example actually is specifically for voice. And let's pretend that what we have here, the 123, 1P, 2P, 3P, is two different circuits. Let's pretend they're an MPLS circuit and a DIA broadband circuit or whatever. And what we're doing is we are sending the voice data down so the Silver Peak technology has worked out the MPLS is actually the quickest circuit between these two endpoints, and it's the most error-free. So it will send the actual voice packets down the MPLS. It will then look at the next best performing circuit you've got and send these parity packets, okay, 1P, 2P, 3P. And because it's voice or real-time traffic, it'll actually send one for one. Guys, this might look like duplication. It isn't, okay? Because duplication basically relies on hope. We're much cleverer than that. If we lose packet, what I mean by that is the parity packets, these 1P2, they're actually based on RAID striping technology, that sort of idea, whereby packet or parity packet 2 is also covered by 1 and 3. So what that means is this. I send my data, my voice packets across. If I lose packet 2, I will rebuild it from parity packet 2. Lots of companies can do that, but this is where we were clever. If we lose parity packet 2 as well, we will rebuild it from 1 and 3. And this is where we can reach those really high levels. Remember, 6% packet loss on a single link, 20% on, with dual links. And that's what the main technology that deals with that. I just need to clarify something else with probably with another slide though, actually, and that's this one. And that is the example I just showed you. We were using 1-for-1 forward error correction because it was voice and it needs to be corrected immediately. For most of your traffic, however, we would use a variable amount of forward error correction. We can see that happening in this slide here, whereby two things have changed. Number one, you will see we've used one parity packet for, in this case, 8, but actually that's our AI at work. It's looking at the quality of the circuits and decided it could do 1 in 8. But that could be somewhere between 1 in 5 and 1 in 50, depending on conditions. But you'll also note in this one, instead of just sending it down the best performing link, we have load balanced across the dual links because this is bulkier traffic and that makes more sense. Hope that answers that question.
I think it does, Richie. Thanks very much. Very clever technology. So there's another question that's come in as well. Andy, I think probably you should answer this one. It's more about the managed service. So somebody's asking if I did want SD-WAN, but I don't want it fully managed as a service, how would Iomart be able to help me design and implement it?
Yeah, absolutely, and I think I had a slide that kind of touched on that. So yeah, our consultants can certainly help you with that. Obviously, we would recommend a fully managed service, but if you've got that, the resources, policy, and your security, then absolutely that might be the solution for you. And of course, yeah, our consultants can certainly help with that.
Excellent. Thanks very much, Andy. Thanks very much to both of you for very interesting presentations, and thanks for those couple of questions. I think that's it for the moment on the questions. So we will be emailing you, all the attendees today, with a link to this recording. So if there is anything that you realise you wanted to ask but haven't been able to, then just respond to that email with the questions that you have, and we'll do our best to answer those and put you in touch with somebody to help you out if you need further information. On the screen, you can just see a quick note of how to keep up to date with Iomart news. And also, if you want some more information about our connectivity services, You can go to the website and look at the connectivity section, and there's a particular part of that that looks at managed SD-WAN, and there's a brochure you can download there as well. Thanks once again to everybody for your time today. We really hope that it's been an interesting and informative session for you. Take care and bye-bye.
Thank you.